Sometime around the year 2030, NASA will lose contact with Voyager 1. It won't be a dramatic moment. There won't be an explosion. The signal will just get quieter, and then it will stop. The day Earth stops hearing Voyager 1, here is what changes for the spacecraft itself. Nothing. It keeps going, at 17 kilometers per second, in the same direction it has been moving since 1977, and it will keep going for the next several billion years. This is the story of the loneliest object humans have ever built, and why it cannot be stopped, even by the death of the sun. This is Voyager 1, launched on September 5, 1977, built by the Jet Propulsion Laboratory in Pasadena. 2 metric tons of titanium, aluminum, gold-plated copper, and one of the most ambitious instrument packages ever assembled. Cameras, magnetometers, plasma detectors, a radio dish 37 meters wide pointed at home. It launched 16 days after its sister, Voyager 2, but Voyager 1 took a faster trajectory and overtook her in space within months. Its mission was supposed to last 5 years, just enough to fly past Jupiter, then Saturn, then end. That was 48 years ago. In March 1979, Voyager 1 reached Jupiter. It photographed the Great Red Spot at high resolution for the first time in human history. It found a thin ring around the planet that nobody knew was there. It discovered active volcanoes on Io, the first volcanism ever observed outside Earth. In November 1980, it reached Saturn. Photographed the rings up close. It found that they weren't smooth, they were braided, twisted, full of gaps and gravitational anomalies that physicists are still trying to model. After Saturn, the original mission ended, but the spacecraft was still working, so they pointed it up. Voyager 1 left the plane of the solar system. It started climbing not toward another planet, but toward the empty space above us. The team in Pasadena let it go. They let it fly. It has been climbing ever since. Right now, as you watch this, Voyager 1 is approximately 165 astronomical units from Earth. That number is hard to feel. Let me try to make it feel real. 165 AU is about 24.7 billion kilometers. A radio signal from Earth, moving at the speed of light, takes around 23 hours to reach Voyager 1. A reply takes another 23 hours back. When NASA sends Voyager an instruction, the spacecraft executes it almost 2 days later. The engineers find out whether it worked the day after that. By the time they react to the result, 3 days have passed. This is not a phone call. This is a postcard. In 2012, Voyager 1 became the first human-made object to leave the heliosphere, the bubble of solar wind that surrounds our sun. It crossed the boundary called the Heliopause on August 25 of that year. Engineers detected the moment by watching the readings of cosmic rays jump and the magnetic field shift in a way that had only ever existed in theory before. The crossing wasn't obvious at the moment it happened. Voyager 1 doesn't have a sensor that says, "You have left the solar system." The only way to know is by watching the particles around it. For about a year before the crossing, the readings had been strange. The flux of low-energy charged particles from inside the solar bubble was dropping. The flux of high-energy cosmic rays from outside was rising. Then on a single day in August 2012, the numbers flipped completely. Solar particles dropped by half in less than 24 hours. Galactic cosmic rays jumped by 9%. The team at JPL spent months arguing about what they were seeing. Some thought it was a temporary fluctuation. Others thought it was the boundary itself. It took a full year of additional data before NASA officially confirmed, in September 2013, that the crossing had happened on August 25, 2012. Voyager 1 is now in interstellar space. It is the only thing humans have ever built that lives there. The thing nobody tells you about deep space is how quiet it is. There is no air to slow you down. There is no friction. There are no atoms to bump into in any meaningful number. Once you're moving, the laws of physics give you only 2 ways to stop: collision or the unimaginably slow drag of a galactic gravitational field over billions of years. Voyager 1 is not going to collide with anything for a very long time. Astronomers have modeled its trajectory through the Milky Way out to about 50,000 years from now. In approximately 40,000 years, it will pass within 1/6 light-years of a small red dwarf star called Gliese 445. It will not enter that star's system. It will not be captured. It will simply drift past, in the dark, at a distance that is closer to a star than the closest star is to our sun, and then it will keep going. 46,000 years from now, it will pass within 1/7 light-years of another star called AC plus 793888. After that, the maps run out, but Voyager 1 keeps going. Around 2030, we lose it. The plutonium-238 in Voyager's 3 radioisotope generators is decaying on a fixed schedule. Every year, the spacecraft produces about 4 watts less power than the year before. NASA has spent the last 2 decades shutting off instruments one at a time to keep the rest alive. The cameras went first, in 1990. The decision to take a final photograph wasn't a scientific one. The astronomer Carl Sagan had pushed for it for years against engineering objections. The spacecraft's antenna would be pointed away from Earth during the maneuver, and the cameras were already at risk from solar glare. NASA ultimately said yes. Voyager 1 turned around. It took 60 frames spanning the entire solar system from the outside in. In one of them, Earth occupied less than a single pixel, a thin, pale speck suspended in a beam of sunlight scattered through the camera's optics. That photograph is called pale blue dot. The dot in it is every human being who has ever lived. Then the imaging system was powered down forever. The cameras were never going to be useful again. Voyager 1 was too far from anything to photograph, but Sagan wanted us to have the picture. He died 6 years later. The picture survived him. The plasma instrument went off in 2007. The cosmic ray system was still running as of 2024, but it's on the list. The team has a quiet protocol for this. They turn off the things that are not strictly necessary for keeping the radio working, and they keep the radio working as long as physics will let them. Some of the engineers managing this process today were born after Voyager launched. They inherited it from the people who built it. They will hand it off to no one. There is no one after them. Edward Stone was the project scientist for Voyager from 1972 until 2022. He was the human face of the mission for 50 consecutive years. He retired at the age of 86. When asked near the end what he wanted to be remembered for, he said only, "I want to be remembered as someone who made it last." He died in June 2024. He never got to find out exactly when the spacecraft would go silent. He'd been hoping to. Susie Dodd, who worked on Voyager as a young engineer in the 1980s, runs the project now. The flight team meets weekly. They debate which next piece of hardware to sacrifice to keep the radio breathing. They are very quiet about it. When the last watt fails, the radio goes dark. The thrusters can't fire to keep the antenna pointed at Earth, and the antenna drifts. Even if there was still power, we wouldn't be able to hear it. That is the moment we lose contact, not the moment Voyager dies. Voyager doesn't die. After we go silent, here is what happens. The spacecraft keeps moving at 17 kilometers per second through the interstellar medium. Cosmic rays will erode it slowly. Micrometeoroid impacts will pit its surface. Over millions of years, the gold plating on the golden record, the gold-plated copper disc attached to the side of the probe carrying greetings from Earth in 55 languages, recordings of whale song, a Bach cello suite, and a child's laughter will slowly dim from particle bombardment. But the disc itself will survive. So will the probe, so will the trajectory. In about 5 billion years, the Sun will exhaust its hydrogen, swell into a red giant, and engulf Mercury, Venus, and probably Voyager 1 will be far away by then. It will not be inside the destroyed solar system. It will simply continue. In about 4-5 billion years, slightly before the Sun dies, the Milky Way will collide with the Andromeda Galaxy. Whole star systems will be flung onto new trajectories. Voyager 1, light enough and far enough out, will mostly drift through the gravitational chaos unaffected. It might end up in a different galactic spiral. It might end up in intergalactic space. We don't know. What we do know is this: by every model we have, Voyager 1 will still be intact, still drifting, more than 1 billion years from now. It will outlive Earth. It will outlive the Sun. It will outlive everyone who has ever heard of it, including everyone watching this video. And it will still be moving. There's a thing physicists like to say when they describe deep space. They say it's not that things travel forever, it's that nothing stops them. Voyager 1 is not going on a journey. The journey is what happens when you push a piece of metal up to 17 kilometers per second and let go of it inside a vacuum. There is no end credit. There is no destination. There is only the persistent fact of it moving, recorded only by the same physics that built every star you have ever seen. I think about that a lot. We built something to outlast us. We did it by accident. The original mission was 5 years. We just couldn't bring ourselves to turn it off. So we kept letting it climb. And now it will be there somewhere, when there is nobody left to remember what it was. The golden record on its side is a message in a bottle. The chance that anything intelligent ever finds it and decodes it is functionally zero. But the spacecraft itself is the message. It is a piece of human craftsmanship moving through the dark for longer than the planet that built it will exist. That is not nothing. That is possibly the only piece of us that is going to last. I want to ask you something. If Voyager 1 is going to outlive every person who has ever existed, and every person who ever will, and the planet itself, What do you want it to be carrying when it gets to wherever it ends up? Comment below. I'll read everyone.